All right. I want to welcome everybody that's here so far. My name is Colin DeCarlo. I'm the organizer of the GPUG, the GPUG PHP users group. This is our February meeting, and it's called Contractual Obligations. And I'm going to move to the next slopes. So first, our agenda. I'm going to do our welcome. Then I'm going to talk about our sponsors for a little bit, the people that make this happen for us. I'm going to be introducing our speaker. Then we'll go on with our show. And at the end of the night, we will have a raffle for prize, not prizes. We're not one of those fancy meetups. We only have one prize. And it is a 1 year's subscription to any JetBrains IDE. We'll be raffling that off tonight. And that is at markraffalo.com or raffle.vehicle.com. All right, let's talk about our sponsors. So we have two sponsors tonight. Well, three really. But the first one is Vehicle. Vehicle is the company that I work for. They've been really good about giving me the time to organize the GPUG. When we were meeting in person, we would meet at the Vehicle offices. They would buy our food and drink. So thank you very much to Vehicle for being a longtime sponsor. They really help make this thing a reality for us. Also to Givelify. Givelify gives us the Zoom link that we're on right now and records our meetups for us so that we can post them to meetups at home. So thank you very much to Givelify. Truly, without you guys and your support, this wouldn't be as good as it is. So thanks again for supporting the GPUG. They've been doing this for some time now, almost 2 years, I think. So thank you very much. All right, so back by popular demand. Last month's speaker decided to speak again this month. That is Colin DeCarlo, that's me. So I am a developer at Vehicle. I organize this GPUG, this user group. I've spoken at conferences, written articles in various magazines, and just really like teaching. And I'm a Canadian, so and based in Ontario. And let's get going. We're going to be talking about PHP obligations. All right, so I'm going to change my screen share. All right, I'm going to make this bigger, don't worry. I'm going to enter into presentation mode. So yeah, so we're going to be talking about some built-in interfaces that are available through PHP's core, and then just one or two that are available through something called the SPL, or the standard PHP library, standard public library. That's countable. And so we're going to see how we can use these interfaces to make our PHP objects. Like for instance, in array access, we're going to teach our objects how to act as though they're arrays. We're going to learn how to iterate over objects, count them, serialize them to like PHP serialized format, and also over to JSON to let other objects know that, hey, if we pass this with JSON encode, this is how we do that sort of things. So without further ado, I have a failing test suite that we're going to make pass together. So if you have questions, just shout them out. You could also put them into the chat and I can try and keep an eye on that. Standard PHP library, yeah. And we'll go from there, okay? So I have our tests here. And the first one we're going to take a look at is our collection test. All right, so actually, I think the first thing I want to do is I'm going to run all of these. And we'll see that they're failing. All right. And then we're going to treat this kind of like an exorcism. So exorcism, if you're unfamiliar, is a website. You can go to exorcism.io. They give you various challenges with a failing test suite. And your job is to make those tests pass by building the solution to their problem. So that's how we're focusing on tonight's stuff. All right. I think the first thing I'm going to do is I'm going to skip all of the tests that are the first test, and we're just going to make them pass one by one. So I'm going to say it colon and then just grab everything to the end. Perfect. And scroll down here and we're going to say this mark skipped. All right. Well, that didn't quite work. Let's see where I messed up. Oh, hello. That one didn't work. Oh. because I have these depends in there. That's why I was finding the its. All right, let's run our test again and see what we've got. Bunch of skip tests. All right, perfect. So this first test here fails. And so the first test here, what we're going to be focusing on is we have this object called a collection. So we see collections everywhere, especially if you're useful or if you're familiar with Laravel, they have the collection object. And the collection object, you can access them as though they're arrays. And that's because those collection objects implement the array access interface. So what we've got here is a collection object, just my own collection object that I created. I'll show a current implementation of that. And in our test, what we want to do is we want to assert that when we access the second attribute of this array here, that we get the value bar out. So right now this is failing because it says that we can't actually use an object of contractual obligations collection as an array. That's because we haven't implemented the array access interface yet. So that's the first thing that we're going to do. So I'm going to jump over to this class here. This is our current implementation that we have. All we've got is a constructor that has the property promotion set up. So we're accepting an array, which we're calling our base, which is kind of like everything we're building the collection on top of. This is going to be the data that we were holding. And if we want to have this collection act as though it's an array, we have to implement an interface called array access. Now we can see that the editor is complaining about something here. And when we look at it, it's saying that we're just not, we haven't implemented the methods that this interface actually exposes. So we're going to add those method stubs now, which is offset get. Can you see this when this pops up? Can you see there's like a little modal window? Oh, no. Okay, so let me change things up a little bit. I'm going to have to share my whole desktop, which I think is okay. All right, so this is the whole desktop now. And let me see if I add the method stubs. Can you see that now? Okay.
Yes.
All right, thank you. All right, so the methods that we have to implement if we're going to be implementing the array access interface are offset get, offset set, offset exists, and offset unset. These are all actions that we can have on our standard primitive arrays. So I'm just going to have PHPStorm implement those, and here they are. So now if we run this now, if we run our test that's failing, we're going to get a different error. And that is saying the return value, so offset get, the return value must be of type mixed, but we didn't return anything. And that's just right here. So the very first thing that we have to do, it's really simple, is I'm going to change this so that instead of offset, it just says key, because I think that means more to me. But the implementation of this is going to be to return, oops, I spelled return wrong, must be nervous tonight, this base at the specific key. And we'll go from there. So let's run that test and hopefully it passes. All right, perfect. Let's go back to our test. If I'm full screen, I wonder if I can split this. That might be better, actually. Let me go, let's see, is there a way to just split this? No. All right, so back to our collection test. So the next test that we're going to implement is it throws an exception when accessing an offset that doesn't exist. Now, this is just a behavior that I chose for this particular object. You could choose to do a different behavior when an offset doesn't exist. You could return null or something like that, but this is just like a consideration that you have to make when you're implementing this interface. If they try accessing a member of this object or this array that doesn't exist, what should you do, right? Like, should you throw an exception? Should you return null? Should you set the value to null or something along those lines? For me, what I expected to do is to throw a runtime exception with a message that says undefined offset. So let's run this test and see what happens. And it fails. And we got, it says undefined array key not there, which is pretty good. That's actually the error that we get because we're just trying to dig into the base array here. So we need what we need to do now in our implementation is just check to see if that exists first. So what I'm going to do is I'm just going to say if array key exists, and if it doesn't, spit it out our runtime exception. So if not array key exists, and what does this accept? It's always one or the other, the array first or the key first. So command P gives you the parameter list. So we're looking for the key first and then the array. So if that doesn't exist in there, I want to throw a runtime exception. So I'm going to throw a new runtime exception with, I forget what the, let's just jump back here and get our undefined offset. All right, so back to the collection now, and I'm going to pop that in here. Just some string concatenation key. So again, checking if it doesn't exist, then we're just going to throw that exception. I'm going to run the test and hopefully it passes this time. And it does, which is great. I think that's good. Let's go back to our test and see what's next. All right. I have a question for the group just about swapping back and forth between the code and the tests. Sometimes it's easier to have the tests on one side and the code on the other. Do we want to try and have that set up? I'd have to exit presentation mode, change the font. Do you think that would be worth the effort?
Yeah.
Okay, let's try that. All right. Iterating is good. Exit presentation mode. All right, so there we go. So now it's too small. I know that, but I will make it bigger in just a moment. Let's get you over here. All right, and then here's our collection code. And let's open up our preferences and we'll change our font. The thing with PHP Storm is like setting the font. It's in about 600 different places. So let's try 24 and see if that updates it. Yeah, okay. It only changed that one though. That's interesting. What about over here? Yeah, 24. Okay, maybe I have to.
Hey, Colin.
Yep.
Just a quick note for you, because I just wanted to make sure before saying anything. From PHP 7, offset exists will be called before offset get is. So your check where you throw an exception can be put into offset exists rather than being an offset get. And if it's not there, it should return null. Apparently, according to a user contributed note. I don't know if that's correct, but I seem to remember they changed some of the logic so that offset get checks offset exists first, or it should do. But
let's see.
Might be worth trying.
Yeah, let's find out. All right, so this is the code here that throws that runtime exception. And what Dave is saying again, this method will get called before this method when we try accessing that array. So let's pop that in here. So I'm going to cut that out of here and I'm going to put it in here.
It may cause an error because it expects to return bool when you're throwing an exception.
Here, let's see. Now that I see that this is responsible for returning a Boolean, I don't believe that that person is correct. I think somebody on the internet might be wrong. Should we ask Daniel to check that out? Let's just return false here for now. And let's run this one test again. So again, we're going to run, it throws an exception and see if that passes. No, it failed. And just so we are using PHP 8.1, we can see that down here. So is that, but that's a user comment, Dave?
Yeah, I just sent the link into the chat.
Okay. Well, let's explore that a little bit more in detail, maybe after the meetup. All right, so back to our passing tests. Maybe we should be committing. I don't know. Here, let's make a commit actually. And we'll just say passes. Ooh. Passes. And then commit. Is it going to give me a warning? All right, so let's get some settings in here and turn those off. There we go. Analyze code, check to-dos. All right, commit. There we go. And now back to the code. All right, so our next test that we've got here is it can set a value at a given offset. Now, this is something I wanted to kind of point out as well. This is an interesting thing about PHP unit, is PHP unit accepts this annotation that says a specific test depends on another test, which means this test, it can get a value at a given offset, needs to pass before PHP unit will even run this test. So for instance, I'm going to run this one test, and we'll see that PHP unit actually ran 2 tests because it needed to validate that it can get a value at a given offset. I wish this was bigger. I'm sorry, it's not. Has to pass in order to run this one. So if I was to come back up to this, it can get a value at a given offset, and I just change the assertion here to assert false. Like, let's say assert true, false. So we'll just make it fail. And then we try running this test again here that has this depends. It doesn't even run it, it skips it. And it says this test depends on that to pass. So that might be something you didn't know. So that's a really interesting and useful way of setting up your tests, that if something it depends on fails, why spend the effort of trying to do it? You can make your test run a little bit faster. All right, back to this now. So you can see here in this test, what we want to do is we want to set a value at a given offset. So we've got our brand new collection, doesn't have anything being passed in, and we want to set the first key equal to foo. And then we're just asserting equals that the collection at first equals that foo value. All right. So let's run this here. And we can see that we're getting an undefined offset first. So let's implement this and make sure it works. So this is this here, offset set. So when we try accessing like this, or we try setting something at an offset, we're going to be calling the offset set. So again, I'm going to call this key because I like calling it key. And it's quite simple. We're just going to say this base at key is equal to value. All right, let's run our test again. And this time we're passing, which is great. That was simple. Now we've got, it can assert that an offset is actually set. So this is the offset exists that Dave was talking about just a few moments ago. So what we're doing here is we've got our collection. We're setting the first key to foo. And then on our test, what we're doing is we're asserting that that is set. So we're saying if something is actually set in our collection, is set is going to return true. And if something is false, if something is not set, is set is going to be returning false. So those are our 2 conditions that we're going to be testing against. And that is, again, implemented using the offset exists, which is responsible for returning that Boolean, true or false. So here, let's change this to key. And for our implementation here, it's really quite simple. All we have to do is just return array key exists. And so that says array key exists. Again, key and then array. So we're going to say key and this base. And we'll run our test again over here. And it passes. So is set, this is the built-in function, can take our array accessible object, and then it's going to be calling offset exists to determine whether or not that returns a true or false value. Use enable zoom through control, scroll, open settings to zoom, select editor. Is that down here? control, right? Sorry, I thought maybe I could make this a little bit bigger. All right. And I think this might be our last test. Yeah, the last test for array access is it can unset and offset. So this is, again, what we're going to be doing here is we're going to be calling the PHP function unset, telling it to remove the first key of our collection here. So in our test, we instantiated our test, we're setting it to foo. This is going to completely remove it. And then what we want to make sure is that when we say, hey, is that value actually set, that we get false back. And again, the implementation of that is based on offset unset. So you can probably guess the implementation. We're just going to pretty much just delegate again down to unset. And we're going to say this base key. Now, what's interesting about unset is unset doesn't care if you pass it something that is set or not set or anything like that. You could, let's make this pass and then I'll expand on that a little bit, but we don't have to do any error checking is what I'm really getting at. So let's run this test. I don't think I had a failing test first. Let me comment out that code first. And then let's run that to make sure that it fails. We can see that it's failing. Right down here, it can unset and offset. So we've got failed asserting that true is false. So now we can add our implementation and run this test again. And now it's passing, which is good. And what I was getting at is, again, unset, we could pass anything we want in here. So we could, for instance, do unset, oops, collection not there, or NTO there, I suppose. Doesn't really matter. And then here, let's just duplicate this as well. And even though it's not set, unset will just say, okay, sure, whatever, not a big deal. So let's run this test again. And it passes, even though not there is not something that was originally set. Also with unset, you can pass multiple values to this. I think even values that don't exist. Maybe. I don't know. Let's just dig in. Whatever's. Yeah, it just doesn't care. It's like a black hole. It's wonderful, actually. If you're into that sort of thing. All right, so that's the array access interface. Again, there's just 4 methods that are part of array access. And if you add it to any object, tell it how to act like an array, and then you can pass it to well, you can treat it like an array, which is actually pretty useful, especially for collections, which we've got here, because the array object or the array primitive in PHP isn't very robust in the things that it can do. So if you want to have more of an object-oriented interface to an array or to a collection, making an object that acts as though it was an array is a good option available to you. All right. Let's move on to our next test. And we're going to be talking about iterators in this next one. So I tried coming up with a test or an object that an iterator would be kind of like interesting for, as opposed to just like an array that you iterate over. And so what I came up with was this object. Can I drag that over here? Yep, called a range. So PHP has a range function. If you're unfamiliar with it, where you can say range 5 to 10, and it will give you back an array that starts at 5 and goes to 9. I think it's open on the low end and closed on the high end. But what if we wanted like an object that was a range that we could iterate over? So that's what I thought would be a fun thing to do to show the iterator interface that we're going to be talking about. So this is our test suite here. Instead of making all of, actually, I could probably make them all, skip them all again here. This just skipped. All right, and then scoot up to the top. I lost my train of thought. We're going to be, sorry, we're going to be showing how we can make objects iterable. So we want to be able to pass them into for loops, basically, and get all of the values out of them. So I thought a range would be an interesting example of that. Oh, and range is inclusive. Thank you. All right. So in this instance, we're going to instantiate our range. It's going to go from 5 to 10. And the very first thing that we have to implement if we're doing the iterator interface is the current method. Implements iterable. No, let's just iterator. Okay, capital I. There we go. So again, we're going to add our method stubs, and again, we have to add valid, next, current, rewind, and key. So I'll explain what all of those mean. So when we access the current value of the iterator, what it's responsible for doing is saying, for this iterator, what's the current value? So if we're looping over it, so if this range was 5 to 10 and we looped over it twice, the current value would be 5, 6, and whatnot. So for this one, when we instantiate our range object with our start and our end, and we grab the current value, we want that to be 5. So let's make this run and pass. All right. So we got an error saying the contractual obligations range current, return value must be of type mixed, none returned. So what we're going to do at this point is, I think, the fastest way to make this pass is just to return 5, but that's not like the right way, but let's just get it to be green for now. This is a true exorcism type way. So now that's green, but that's not right, right? So we made it work, but we didn't make it right. I think what we have to do is we actually have to keep track of what our current value is of our range. So I'm going to add a property called current, and then we're going to have this current method just return that property. So I'm going to say this current equals start, not this start, just start. And then I'm going to make that a private attribute. All right. And then we'll return it here. And run our test again. And this is the correct implementation of this. Or right, I suppose. Correct is such a loaded term. This is a way of making this work. All right, moving on. The next method that we have to implement for the iterator is the next. And what next is responsible for doing is just kind of like moving the pointer for the current value to the next element of the iterator that we're working on. So in this instance, we create our range from 5 to 10. If we call next, we're going to be bumping it up by 1. So then we're going to say we would need to make sure that the current value is now 6, because 6 follows 5 if we're counting by 1. Let's implement that. I thought that was kind of funny to hear. All right, so right now we're returning 5 because next isn't doing anything right now. So let's make this pass. I think the easiest thing for us to do at this point is to just say this current plus equals 1, which is our step value. And let's make this run again. There we go. So now that's passing. So far we've covered current and next. What's next? Some error checking. So what we want to make sure now is, oh wait, it returns the key value of the current index. Oh, key, sorry, not error checking. Must have misspoke. So in your for each arrays, right, if we're iterating over this object, it's going to have a key value, right? You can say for each, we could type, for instance, for each, its key value as, no, for each range. I was stuck in JavaScript land for a moment, as index value, right? The key value, or let's call this key actually. That's what this key method is responsible for returning, is this key here. So I figured for our range, the key value would be just like where we are in our iteration. So if like our loop counter, basically. So if we instantiate our range from 5 to 10, and we don't iterate over it, we don't move the counter or anything like that, we assert that our key is going to be 0. And then if we move our counter with next, then we want our key value to be 1. So think of it like a loop counter. So what we're going to do at this point is implement key. So I felt what we could do for key is we could return, we don't have to keep track of it. We can infer it based on the current value and our start value. So I could say this current minus this start. If we wanted to, we could have like also a key value and instantiate that to 0. And then whenever we hit next, we could increment that. But because we're stepping just by 1, we can subtract our start value from our current value and get the key that way. So let's make this pass. Oh, you know what? We have to run it first. Sorry. All right, so now the test is ignored. Oh, of course. Now let's run it. See, that would have been embarrassing. All right, so now it's failing. So let's implement it here. And again, let's make this run. All right. So some people reading this might think, hey, that's actually kind of clever, and we might want to avoid clever code. In that case, if we wanted to, again, like I was saying, we could just say, we could have another property called key, and we can start it at 0. Let's implement that as a private property. And then whenever we hit next, we'll just increment key. Then our key value, instead of returning current minus start, could just return this key. And that might be simpler for some people to, oops, spelled return wrong. That might be simpler for people to understand if they're reading this code again. Let's see if our test continues to pass with that refactor. And it does. So maybe we'll keep that. Let's see what happens. All right, so our next test is it returns true when the range has not been exhausted. So there's a method on our iterator called valid. And valid, every time in our for each loops or our for loops, or well, for each loops, every time we're iterating over it, it calls valid to check to see if our iterator is still okay, meaning that like we still have values to iterate over. So if there's still more space left in whatever we're iterating over, valid is responsible for returning true. If it's been completely exhausted, it returns false. So in this instance here, where we're instantiating our new range, we haven't iterated over it, we haven't done anything, valid should return true. So that means because we haven't done anything with this yet. So let's get this to pass. So I'm going to run it here. And it says, oh, the return value must be a Boolean, but none's actually been returned. So valid is here in this implementation here. And I'm just going to return true. That's going to be the simplest thing that we can do at the moment. Or array. There we go. Let's make this run again. And we're passed. Now, the opposite side of that is we want valid to return false when we've completely exhausted our range here. So I've got a range that goes from 1 to 2. And I'm iterating over it by 1. And I want this to stop basically when there's nothing left for it to go through. So I'm going to assert that valid is false when when there's nothing left. So when we've hit the end of our range. So let's change that. So I think the way that we could do that is I could just say, I could return if this current is greater than or equal to our ending value, which is the end of the range here, which we've got as 2. So I think that that should keep, I think that should make this test pass. Oh, it returned it. Oh, wait, false. Current is greater than or equal to. It returns false when the range has been exhausted. Oh, I'm going to need some help from the crew here. This current, if this current is greater than or equal to this end, it's going to return. Oh, wait, less than. That was easy. Less than or equal to. Let's run that and see if we get it to pass this time. No. Uh-oh. All right. So why can't I? I'm having some problem. I think it's this current is less than this end. Let's try that. All right. Rod, you might be my savior. Hey, there we go. Yeah. Okay. Sometimes those fence post errors are always hard to gather and wrap around your head. So thank you very much for your help, Rod, on that. So again, the basis for valid is there more to iterate over? If there is, yes. If there isn't, no. So in this instance, if our current value is less than our ending value, it's valid. If it's not less than, so if it's equal to or greater than, it's going to be invalid. So yeah, that makes a lot of sense when you say it like that. Thanks a lot, Rod. All right. So the next thing we need to do is we need to implement this idea of rewinding our iterator. So if you could only iterate over the value one time, that wouldn't be entirely useful. So if we want to be able to rewind, we want to be able to go all the way back to the beginning of our iterator when we call rewind. So let's do that. So in this, I'm going to run this. Rewind's job again is to just reset everything and make it fresh as though it was the very first time again. So in our test, what we've got is we're instantiating our range from 5 to 10. We're moving our counter. So now our current value would be 6. We're rewinding it, which is supposed to send it back to the beginning. And then we're going to assert that our current value is again 5. And you can see here when we failed it, we failed that 6 matches 5. That's because rewind's not currently doing anything at this moment. So let's get this to pass for us. And so the easiest way to do that again is we can just reset our current value. This current is equal to our starting value. And let's not forget to reset our keys as well, because we're tracking those independently now. So we probably going to want to say this key is equal to 0. All right. And let's run this and see if it passes. And it does. Now let's run the whole suite. Oh, actually, what do we got in here? Oh, it can be iterated over. Oh, so this is like everything that the iterator actually builds up to. Just calling current, next, rewind, all those sorts of things. You're not really actually going to do that in real life. You're going to have an object that implements the iterator interface. And the reason for that is because you want to use it in a for each loop. So let's run this and hopefully it should pass for us. I'm a little bit nervous, honestly. Oh, it passed. Wonderful. So the test was we created a range from 1 to 3. I'm going a little bit too fast. I apologize. From 1 to 3. And what we're going to do is we're going to iterate over that range and just collect the values that it's spitting out for us, our index and values. And then what we were going to do is we're going to assert that this expected value, this is what we expect our range to give us, is what we actually got. So we were expecting an array with 2 elements, key 0, 1, and then 1 and 2, because it goes from 1 to 3. And our actual value was that, so the test passed, which is actually quite nice. The next thing is, a new interface, which is nice. a test that says it returns the size of the range. Before we do that, actually, I think that there's a little bit of refactoring to do. There was one thing that kind of like stuck out at me is when we did the rewind here. You can see here we have this code. This current equals this start, and this key equals 0. This, if you remember, looks very familiar to this code right here. This current equals start, and this key equals 0. So I think what we might be able to do to keep that like our test passing and whatnot is I think we could remove this duplication and in our constructor just call the rewind method. And I think that will set our current value to our starting value because it's coming in here, and then reset our key value. So I'm going to try that and see if that works. This rewind. And so the test was this test. So let's run that again and see if that passes still. And it does. That was a good refactor. I like that. I don't think that's clever. I don't think so. Maybe. Thanks, Rod. All right, let's move on now to this next test. Don't be clever ever. It's true. I don't think that's clever. I don't think that's clever. I don't know. The debate can rage on into the night if we want, but let's just keep moving. We talk about it later. This one is it returns the size of the range. Now, what's happening here, let's just run this and see what the error is that we get back from this. We're going to instantiate a range from 5 to 10, and we're going to assert that when we pass our range object to the PHP count method, that it gives us back 5. It says, hey, there's 5 values in this range. And so we're getting a type error here. It says, if you can read this, type error count argument 1 must be of type countable or array, contractual obligation range given. So what this is telling us is that we have to implement a new interface in order to be able to pass our range object to count. And what we have to implement is the countable interface. Now, you might be wondering, well, why wouldn't an iterable just have a count on it or something along those lines? And this is what I'm going to give a nod to solid principles. The I in solid stands for interface segregation principle, which is basically saying keep your interfaces small, because there might be some objects that you can iterate over, but you don't necessarily want to count the size of, or there might be things that you want to be able to count, but not necessarily iterate over. So it makes sense in that instance to keep those as 2 separate interfaces. And if you want an object to be able to do both of those, then implement both interfaces. In PHP, you can implement as many interfaces as you want. So just kind of like a word to the wise is when you're slicing up these interfaces, the goal is to kind of keep them about as small as you can. Kind of keep an eye towards something called cohesion, which is when a number of properties kind of work together. So you can see in our iterator one where we've implemented current, next, key, valid, and rewind, we're all kind of like, we're all dealing with just a couple of properties that are very highly cohesive. If we implement count, count isn't really gonna, well, count actually does touch both of those properties. That's a bad example. But the idea is keep your interfaces small, and we can dig into that a little bit too if you really want. So let's add another one here. Countable. Again, we're getting an error here, just saying, hey, we have to implement the method count. So let's do that. Add those method stubs down here. And the easiest way for us to count this method, now if we run this, we're going to get a different error. It says it must return a value of type int, but it's not returning anything, is to just subtract our ending value from our starting value. We're going to return this end. So big number subtracted from smaller number. So smaller number subtracted from bigger number, but you write it the opposite. So there you go. Let's run that again. And now we're passing. So that's great. So that's how we implement countable for our range, at least. All right, so those are two other interfaces that we talked about. That's the iterator. Again, the whole point of doing the iterator is so you can use them in the for each, like up in here. And in order to do that, we have to implement the current, next, key, valid, and rewind methods. If we want to be able to count our objects, to say how big are they, we have to implement the countable interface, and that only has one method in it called count. It's responsible for returning an integer, which is just however big you think that object is. That could be maybe the number of lines in a file, or in this instance, how big our range is. It could be the number of records in it returned from a database result, any number of those sorts of things. It's up to you. All right, let's take a peek at a little cheat, I guess, or a shortcut for implementing an iterator. And that is going to be through our another range class and another range test. So iterating over things is something that people do a lot of. And so there's a lot of built-in things that are available to PHP in the PHP core that kind of like give you a helping hand if you want to iterate over things. And so one of those is actually you can implement an interface called iterator aggregate. And the iterator aggregate interface only makes you implement one method, get iterator. And that iterator is responsible for returning an object that implements the traversable interface. And the traversable interface is a special interface in PHP where userland code can't actually implement it directly, but like if something is implements iterator, it will also pass the traversable check. So I'm going to go to the PHP core, the PHP docs, and we're going to look at the iterator that I'm going to be talking about here. So iterator aggregate is the one that we're looking at. And that is responsible for returning traversable. Let me think. And where are the docs for what I want to find? Iterator aggregate, get iterator, array iterator. I'm just going to search for it. There's a whole bunch of iterators that just come for free in PHP. So you have like, the one that we're going to look at is the array iterator, but there's file system iterator. So if you want to iterate over directories, there's glob iterator, which is like if you're at a terminal and you type ls star and you get everything, that star is something called a glob pattern. So there's a whole bunch of like built-in iterators that you can instantiate and use that PHP gives you. There's a lot here. There's hours worth of content to go over, so we're not going to do that. But what we can do is we're going to implement an array. Yes, iterator. I've never used that one. We're going to implement the array iterator. And the array iterator, when you instantiate it, all it expects is an array. And it gives you back something that implements a seekable iterator, which probably goes up to implementing our iterator, which is something that's traversable. So in our code here, if we're implementing iterator aggregate, and we want to be able to iterate over our range, I'm going to run this test, it's going to fail. All we actually have to do is return basically a new array iterator, and it's going to take care of the current, next, valid, rewind, all those things for us. And all we have to do is pass it an array of whatever our range looks like. So I'm gonna just use the range built in PHP method, passing in start and going to this. And I think I need to subtract 1 from it based on what we learned the other day about it being inclusive, because I think our range objects, the way I implemented them, are closed. So let's see if this passes. And it does, which is wonderful. So now all that work that we did just maybe, oh, it's 8 o'clock already, maybe 20 minutes ago to implement the iterator interface can all be done with iterator aggregate. And by passing something, by implementing the get iterator method that returns something that is traversable, whatever you want. That's like a cheat code, which I think is pretty good. We've just got one more thing to look at, and that is our serializable tests. So I figured something that we'd be able to use for our tests with something that kind of represents a database model. So picture an object that represents a record in your database. And so I called it a DB model. And so in our tests, what we're going to be looking at is how can we serialize those objects into a state that can get written to disk or maybe sent across the wire or something like that to maybe your front end, or maybe pushed onto a job queue or something along those lines. So what I decided what we would do is we would implement, this DB model. So let's look at this first test here. It serializes just the ID of the record. So if we're talking about database records, that data is kind of like, it shifts around a lot. And the only real constant, if we're like uniquely identifying something, is by its primary key. And so for this particular implementation, I chose that the ID attribute of that record is the primary key. So if we're serializing it, we're not really sure how long that data is going to stay at rest. It could stay at rest for just a few milliseconds. It could stay at rest for like days or months, or even. You should really only be considered when you're serializing just the information that you need to bring that data back to life. So we're only going to be serializing just the ID of that object. So here, what we're going to do is we're going to grab a record out of our database. Right now, I just have a static in-memory database right here on our DB model. And there's going to be a method that says grab it out by ID. I'm going to be passing in 42, and that's going to line up with this record here. So our by ID method here, all it's doing is returning a new instance of our DB model, passing in the attributes from our database at that ID. So that's all it's going to do. That's how that all works. The toArray method just returns this array. So what we're going to do is I'm going to just make sure that this passes without the serialization. It should. And it's passing. So we know now that the by ID method will reach into this records database, pull out the appropriate record, and give it to us. So that's kind of like our pre-assertion really for this. I hope that makes sense. Now, when we call serialize, when we pass an object to serialize, PHP is going to do its best to like turn that into a text record. And we can see that this is the expected value of our DB model. So the way it kind of works in PHP is like serialize code. I went over this last month when we talked about sleep and wake up and serialize, unserialize, is we have an object, and that object, like name of it, is 30 characters long, which is contractual obligations DB model. And then there's one attribute, it's a string called ID, and its value is an integer, which is 42. That's how we read that. The good news is we don't have to actually read it. The computer does it for us. So let's run this test, and this should fail for us. And it does. And that's because we're not implementing an actual serialization method in here. We're not implementing like the serializable interface. So it's just doing its best to serialize it, and it sent it down to a binary string. So that's not what we want. So if we want something to be serializable, we have to implement the interface. I spelled implements wrong. That could have taken hours to sort out if you guys weren't here. Serializable. And again, we're just going to see what methods we have to implement. And those methods subs. This is an interesting thing that I learned just when I was putting this talk together. We have to implement 4 methods because I'm using PHP 8.1. We have to implement the serialize and unserialize magic methods, which we learned about last month. And then these methods from the serializable interface, serialize and unserialize. If we were using an older version of PHP like PHP 8 or PHP 7.4, I think we'd only have to implement the serialize and unserialize methods of the serializable interface. But because we're using PHP 8.1, we'll actually get deprecation errors if we don't implement the serialize and unserialize methods. So that was something new that I learned putting this talk together. So again, here's our methods here, serialize and unserialize. Serialize is responsible. Actually, I don't even think these are even called because I'm using this version of 8.1. We're going to focus on the underscore serialize method, which is responsible for returning an array. So let's, and that's just going to be the array of properties and attributes that I actually want to be serialized. So for here, we can return just an array that has a key of ID and this attributes ID. And hopefully this will make this pass now. And it passes. Now let's say, for instance, let's just make this fail just so we can see what this string actually looks like. That might be interesting to some people. So let's return, instead of this array like this, let's just return the attributes that we actually have, which again is just a private array of these attributes up here. Let's run that again. And you can see here, I hope this is, I'll copy this. This might be too small for some people to read. I'll just put that into a scratch. Text. It's right here. So we expected this DB model that has one attribute, which is an ID of 42. And actually what we ended up getting was this DB model that has 2 attributes, the ID and our name, which is actually Colin here. So that's not what we wanted. We only want to have just the ID at rest. Ooh, not to array. Ooh, we could call, no, we can't call to array because that gives everything. So let's do ID and this attributes ID. So again, that's how we make that pass. And we'll run that test again. And now it's green. Let's go back to our test. All right. Now it hydrates the model when unserializing. So the next thing you want to do when a model gets serialized is you want to bring it back to life. You want to breathe life back into it. So in order to do that, what it does is it takes the serialized string. Let's give ourselves some more space so we can look at it. It takes the serialized string. If we pass it to the unserialized method, we should get back a DB model. And what we want is we want to make sure that we get everything from our database back out, even though we're just passing in this ID. So let's run this method and it's going to fail. The reason it's failing is because it says typed property DB model attributes must not be accessed before initialization. Oh, that's because we're calling to array on it. And so there's no data that's actually here. The data here, let's just put a breakpoint here. Actually, there's no, let's just say foo equals data, and we'll get a look at what data actually is. So I'm going to put a breakpoint here. Data is going to be, I think it's going to be array of this data here. So it'll be an array that has an attribute ID and a value of 42. Let's just validate that. So here we've got data. I wish this was bigger, but you can see here, I wonder if I make it, yeah, okay. Let's just spit out data. It's small again, but it's an array that has an attribute ID or a key value at ID with a value of 42. So that's that. So I'm going to let that play through and fail again. And then what we want to do again is just say this attributes equals, we're going to reach into our database and we're going to grab the record at ID 42 and set that equal to the attributes that we actually have. So the way that we do that is we say static, colon records data at the ID. And that should be enough for us to set the attributes back. So let's run that test. And now it's passing. So again, our unserialized method just effectively went to our database and pulled the record out by its ID. All right, now the next one that we want to do is serializing to JSON. And so if we want to be able to pass our object to the JSON encode PHP function, it has to implement something called JSON serializable. So let's implement that interface. JSON serializable says you have to implement one method called JSON serialize. Again, the serialize and unserialized methods from serializable as well. So that's interesting. Is it going to do them both again? No, it's not. Oh, it did. Oh, that's a bug in PHP Storm, I think. So we already have these methods implemented right up here, serialize and unserialize. So I'm just going to delete this block of code here. So JSON serialize here, what we want it to do is to JSON serialize. What you're responsible for doing is returning an array of the attributes that you actually want sent down to JSON. And so in our instance with our DB model, what we want to send down to JSON is the entire attribute set. So the ID, the name, whatever we have in our DB model. So I'm going to have this return this attributes. Now you see the return type here is mixed, and that's because a number of things can be sent down to JSON. You can JSON serialize plain strings, integers. Like the JSON format is really flexible as to like what like a properly JSON encoded value is. So a lot of people are really kind of locked into the idea that a JSON encoded value is like an object literal that has braces and whatnot, but that's not actually the case. It can be an array. It could be, like I said, an integer. It could be a string. It could be an object literal, but it doesn't have to be. So that's why the return value on JSON serialize is mixed, because it can be anything. But now, because I'm just returning an array and I'm only ever returning an array, PHP Storm is telling me, hey, you can actually narrow this type down to an array. So we might as well do that. And let's run this test here. I didn't actually run it when it was broken. Sorry. All that build up for nothing. So here it's failing. What we're doing is we're expecting back our JSON encoded value. And so that's what this is going to do for us. Going to run that test again. And that's it. And now it's passing, which is pretty great, actually, I think. So we covered a number of interfaces tonight: the array access, our iterator, our countable, our iterator aggregate, and then finally the serializable interfaces and JSON serialize interface. And those are just a select few of the core PHP interfaces that it makes available to us for us to implement and make our objects do whatever we want them to do. And that's it. Thanks everybody for coming out. That's the end of the presentation tonight. You're welcome to stick it out and talk for a bit. I hope you enjoyed that. I'm going to stop my share and go on from there.